So for example, a class A torsion balance has a sensitivity requirement of 6.5 milligrams. Explain using calculations how you would weigh 15 milligrams of atropine with an error of plus or minus 5% using lactose as diluent. So I guess the first thing that we need to do is to identify what these numbers are saying. First step, we're going to have to determine what we need to weigh and whether or not it can be weighed on the balance. So in order to determine that, well, when we determine that, we see that we need to weigh 15 milligrams of atropine. But in the question, it didn't say what the least weighable quantity is. So therefore, we're going to have to determine that. So using the sensitivity requirement and the percentage error, we are able to determine the least weighable quantity, which states, or which is calculated to be 130 milligrams. So this clearly means that the 15 milligrams of atropine that we are trying to weigh cannot be weighed. So how are we doing? Let us take a look now at weighing solids, and this example is going to show us how to use the Aliquot method. So clearly 15 milligrams cannot be weighed by this balance, so therefore we are going to have to now select a multiple of the desired quantity that can be measured with the required precision. Now it means then that we are going to have to find how many times can I get what I want to weigh, which is 15 milligrams, out of what I can weigh, which is 130 milligrams. And in order to determine that multiple, and we're going to discuss what that multiple is going to be used for, we determine that by dividing the quantity requested into the least amount measurable, and in this case the least amount measurable, or the least measurable or weighable quantity is 130 milligrams. When we divide that, we get 8.6 multiple, or we can call that 8.6 factor. What do we do with this factor? Now this factor is what we're going to be using now to determine the total mixture that we are going to prepare. Now remember, we had said that using the Aliquot method, or the least weighable quantity method, or the serial dilution method, we are weighing more than we need to make a mixture that is concentrated such that we can remove a portion of that mixture that will contain what we want. We want 15 milligrams, can't wait. So now what we are going to do is determine by what multiple now can I prepare a mixture by such that I can remove a portion of that mixture such that it will contain 15 milligrams. And we're going to use a factor of 8.67. Now we can use a factor that is greater than 8.67. So in other words, we can use 9, we can use 10, we can use 11, etc. But we cannot use a multiple less than 8.67. If we use a multiple, say 8, then it means that when we're doing our calculations, and even if we use that multiple to determine the total mixture we want, so that we can remove a portion, the portion that we are going to remove is going to be less than 130. So the rule of thumb is, when you calculate your multiple can remain as what you calculated, even with this decimal, or greater. Of course, the greater your multiple is. So if I choose a multiple of say 20, it means that my mixture is now going to be 20 times the amount that I want to weigh, which might not be practical in many cases, as well as it might not be as conservative because you're using more than you have to, right? Just consider that if each gram of each of these powders that you're going to make is costing, say, $20, you want to use as little as possible, or to be as conservative as possible in terms of the amount you're weighing and measuring. So we're going to use a factor of 8.67 for this calculation. So step 3 then is to determine the total drug to be weighed based on the factor that we calculated in step 2. And I said we're going to use a factor of 8.67, but you could use a factor of 9. You could round it up, right? If it is that you got a factor of 8.23, we're not going to round down to 8, because it means then that the amount that we are going to weigh to get what we want is going to be less than the least weighable. So always use the factor calculated or greater. You can round up but not down. So in order to determine the total drug that we have to weigh, remember we need 15 milligrams of atropine. We can't wait. We're now going to have to multiply that multiple by the atropine that we want to weigh. So 8.67 times 15 milligrams is going to give us 130 milligrams of atropine that we are going to weigh. Can't weigh 15 milligrams, so we are weighing 130 milligrams. It is 8.67 times more than the 15 milligrams that we want. So if we are weighing 130 milligrams of atropine, then it means that the atropine is now going to be mixed with a diluent to get a total mixture, and that mixture too is also going to be 8.67 times more than the 15 milligrams. So, as I had said, 8.67 times more than 15 milligrams than what I actually need based on the factor. So step 4 says we need to determine the total quantity of mixture to be prepared and the amount of drug that can be weighed by the instrument times the multiple is how we obtain that. So the multiple is 8.67 and the amount of drug that we are going to weigh is 130. So the total mixture will be 1,127.1 milligrams. What does this mean? It means then that the total drug to be weighed plus the diluent is going to give me 1,127.1 milligrams. So, to determine then the amount of diluent that we need, we have to subtract the quantity of drug to be weighed, which is 130, from the total mixture, which is 1,127.1 milligrams, to get the diluent. So the formula is going to now be atropine 130 milligrams and 997.1 milligrams is the diluent. What does this really mean then? What is it saying? How am I going to get my 15 milligrams? Well, I can weigh 130 milligrams. I can also weigh a diluent of 997. When I mix those two powders together, I am now going to get a total of 1,200 and something milligrams for total mixture. And that total mixture now, I'm going to remove a portion of it that will contain 15 milligrams. And how do I do that? I divide it through by the multiple to determine the amount of aliquot that I need to weigh. So total mixture divided by the multiple, because the amount of drug you're weighing is going to be 8.67 times more than the 15 milligrams, and the total mixture is going to be 8.67 times more than the amount of drug that you're actually going to weigh, which is 130. So therefore, things are in multiples of 8.67. So when you divide the total mixture by 8.67, you're going to get 130 milligrams. Alright, so that is how we determine it. And you can also use ratio and proportion to determine if that is true. you can now say 130 milligrams. Let's look back. You can say 130 milligrams is contained in the 1271. But you want to find out now what proportion of this mixture will contain 15 milligrams. And when you do your cross multiply, you will end up with 130. Alright? So that is how we use the Aliquot method to weigh small quantities. Yes, so as I was saying earlier, that the amount of diluent is obtained from subtracting 130 milligrams from the total amount of mixture calculated, and that will give us the amount of diluent. And in this case, the diluent could be lactose or starch, any such powder that will not confer any therapeutic effect, but it serves as a vehicle for the drug. Now, definitely, you are going to have to determine the concentration of the mixture, and in this case, the concentration of the mixture is 11.53%. So it means then that if I make an 11.53% mixture, and that mixture has an amount of 1,127 milligrams, I should be able to remove 130 milligrams of that mixture. And that 130 milligrams of that mixture is now going to contain 15 milligrams. And we can check that. We don't have to take the word, we don't have to guess it. We can prove it. How do we know that this is going to contain 15 milligrams? Well, because you increased everything, you increased the amount of drug to actually weigh by a factor of 8.67. So we got 130 milligrams. And we also determine the amount of mixture, which is 8.67 times more than the amount of actual drug that will be weighed, which is 1,127. When we divide that total mixture by the factor, we're going to get 130 milligrams. And this suggests that the 15 milligrams is contained in that. Maybe you won't see it that way. So let us use ratio and proportion and leave it out and try to prove that that is correct. Now we know that 130 milligrams of active drug is contained in a total mixture of 1,127 milligrams. So if that is the case, then we can determine how much of the mixture will contain 15 milligrams. When you do that, you find that it's going to be contained in 130 milligrams. We do the corrections quickly. So you can just double check that on your calculator. So if it is that you can't see it in that way, then you can always prove it using ratio and proportion. Alright? But definitely, if you follow the steps, then you know that your aliquot is going to be the total mixture divided by the factor, and whatever you get will be the amount of mixture you need to remove that will contain your 15 milligrams of drug that you couldn't weigh in the first place. An alternative method of calculating that is using the following equation, which is the amount of drug in total mixture divided by amount of total mixture, which is equal to the amount of drug in the aliquot and the weight of the aliquot. So again, we are going to determine the least variable quantity, which is 130 milligrams, just as we did the first time around. And then we're going to solve for the unknown in the formula, which is the amount of total mixture. Remember, we didn't know that, but we know the amount of drug in total mixture, we know the amount of drug in aliquot, and we know the weight of the aliquot. How do we know the total amount of drug in the mixture? Because that is going to be the aliquot. The aliquot is going to be the least weighable quantity. So let's see. So the amount of drug in the total mixture, amount that can actually be weighed is 130 milligrams. The amount of drug in the aliquot, that is the amount that you're going to remove from the total mixture that you're going to be making in order to weigh what you want, is going to be 15 milligrams. And I'm sorry, let me say that again. The amount of drug in the aliquot, and that aliquot is the amount of mixture that will contain the drug you want, which is 15 milligrams. And the amount and the weight of the aliquot, of course, is going to be 130 milligrams. How do I determine that? We determine that because we want the aliquot that we want to remove to be 130 milligrams. Just bear in mind that whatever is weighable or whatever will be weighed must be 130 milligrams or more. Okay, so the amount of drug in total mixture can be 130, it can be 140, it can be 150, right? And the amount of drug in the aliquot, we know it's going to definitely be 15 milligrams. You can't change that. And the weight of the aliquot is going to be 130 or more. Okay? But we just decided that we're just going to keep it simple and use a least weighable quantity as the weight of the aliquot. So remember, the aliquot is what you're going to remove from the mixture that will contain the amount of drug you want. The amount of drug in that aliquot is what you want but can't weigh, and the amount of drug in the total mixture is the total amount of drug that you're actually going to weigh in order to get what you want. Okay, so we want to determine the amount of total mixture because we don't know that, we know the other terms. So therefore, just plugging that into the equation, we get 1126.67. And we're getting 1126 because we're pretty much sticking to 130. But I'm only saying that you can use 130 or more. You cannot use less than 130 or else it will not be weighable, because less than 130 is not weighable anyway. Okay? So again, because we had determined the total amount of mixture, meaning this total amount of mixture is going to contain diluent, and it's also going to contain the amount of drug that you're actually going to weigh, which is 130. You now are going to have to determine the total amount of diluent. Just as how we did it the last time, subtract 130 from the total mixture to get the amount of diluent. So what does this mean, Miss Bryce? This means that I am going to mix 996.67 milligrams of diluent with 130 milligrams of atropine, mix them together homogeneously, and then I'm going to remove 130 milligrams. So just to recap, the atropine powder mixed with the diluent is going to give us a total mixture of 1126.67 milligrams. But that doesn't mean anything to us unless we determine what proportion of this mixture will contain the 15 milligrams of atropine that we want. We want this 15 milligrams. So we can't weigh 15 milligrams because the scale can only weigh 130 milligrams at least. So therefore, we weigh more than we want to make a concentrated mixture. And from that concentrated mixture, we decide how much of that will contain 15 milligrams. We had already established that the amount of aliquot will be 130. We made it so, and we applied it to the equation. We can determine if this is correct, because based on what we had said, the aliquot will be 130 milligrams, and the amount of drug in the aliquot will be 15 milligrams. So we can determine if this is correct. So let's double check. If 130 milligrams is 130 milligrams of atropine is contained in the 1126.67 milligrams of mixture, then the 15 milligrams that we want, this 15 milligrams up here, will be contained in X, and X will be 130. check it with your calculator and you realize that it is correct. So again, the percentage concentration is not far off from what we had calculated before, 11.5% mixture of 1126.6 milligrams. We should be able to weigh 15 milligrams using an aliquot of 100, by removing an aliquot of 130 milligrams. If we are going to be using this scale, the sensitivity requirement 6.5 milligrams and an error of plus or minus 5%. Now you might be saying, but Ms. Price, I only want to weigh the 15 milligrams of atropine. What's up with this diluent? Why is it there? Remember, the diluent is just a diluent. It is just there to facilitate the carrying of this 15 milligrams. So it's really bulking up that 15 milligrams, for want of a better word, so that the patient is able to handle it, you are able to weigh it, the patient is able to take that particular dose, if that is a dose. And we're going to see the application of this method when we are doing divided powders, which we will do shortly. Alright, so in summary, the percentage error is measured value divided, the measured value minus the true value divided by the true value times 100%. Sensitivity requirement is sensitivity requirement divided by the quantity desired times 100%. The percentage error is sensitivity requirement divided by quantity desired times 100%. And of course, you can always rearrange this formula to determine either the percentage error or the quantity desired or the least weighable quantity. As is seen here, with least weighable quantity sensitivity requirement divided by acceptable error times 100%. An error in weighing of plus or minus 5% or less is acceptable, and least measurable quantity is 20% of the capacity of the measuring devices. So we're going to stop here and we'll pick up in our next recording how we measure small quantities that our measuring devices are unable to accurately measure. Alright, thank you so much for listening, and we will catch you next time.